Hello, Algebra 1 students. We are in Unit 3. We're in Week 2, Family Function Syllabus. We are in Tier 1, given a linear function. Let's check off our booklet. So here we're given some linear functions, and linear functions are written in the form of f of x equals 1/2 times x minus 2. You guys are probably familiar with seeing y equals mx plus b, which is just slope-intercept form of a linear function. I'm going to shrink this down. So what I want to do here is I just want to grab my slope-intercept form of this equation right here again and graph it on the Cartesian plane to the right. So, and if you remember, f of x is the same as saying y. So we could just put when we have the outputs, we just put y there. We put it on the y for the Cartesian plane. So I always like to start with real simple numbers. So 0 is always what I go for my midpoint, and then I go 1, 2 for my inputs to the right of 0, and I go -1, -2 to my inputs to the left for 0. So let's start plugging these inputs into our function. So if I plug -2 into this function, I get 1/2 times -2, which is just -1. -1 minus 2 is -3. If I plug -1 into my input, I get -1 times 1/2, which is -1/2, minus 2, which is -2/2, which is -2.5. If I plug 0 into my function f, then I get 1/2 times 0, which is 0, minus 2, which will give me an output of -2. If I plug 1 into this linear function, I get 1/2 times 1, which is just 1/2, minus 2, which gives me an output of -1 and 1/2. And then if I plug 2 into this linear function as my input, I get 1/2 times 2, which is 1, minus 2, which is just -1 as my output. And if you remember from a table, these are now our points that we can graph on our Cartesian plane. So if I take these over as my points, I go -2, 3, so I come back 2, down 3, that's my first point. If I go -1, -2.5, I go back 1, down 2.5, there's 1, there's 2, 2.5 would be about right there. I'm going to zoom this in a little bit. 2.5 would be about right there. Doesn't have to be perfect because it's just a sketch. Then I got 0, -2. So 0, I'm right there at the start, at the origin. And I come down to -2. Then I have 1, -1.5. So I come over 1, going to the right on the Cartesian plane for positive numbers, and down 1.5. So there's down 1, and then down 1.5 would be about right there. And then I have 2. So 1, 2, and then -1 would be down to here. So let me clean this up a little bit of my counting. So these are the dots from our table. And then we can just sketch our line through the dots, or our linear function, as we would call it. And notice as the linear function is moving from the left to the right, as it's going left to right, it's climbing or going upward in motion. So left to right, climbing, tells us that our linear function is increasing. Because just as we read left to right, we in words, like in books and in magazines, we also read functions left to right. Let's look at another one. Again, I like to pick real simple inputs, and I'll go a little quicker with this one. You can pause if you need to. So if I input -2, I get -2 times -4. That's 8 plus 4 is 12. -1 times 4 gives me 4 plus 4 is 8. 0 times -4 is just 0 plus 4 is 4. 1 times -4 is just -4 plus 4 is 0. And 2 times -4 is -8 plus 4 is -4. So some of my points, as you can see, might be off my graph, but that's okay. We can do the best we can. So let's start with the points over here. I'll start on the right side of my table. Usually I start on my left, but I'll start on my right. So I'm going to go 2, 1, 2, and then I'm going to go down 4. 1, 2, 3, 4. So there's my first point. Then I'm going to go over 1 and then down 0. So my second point is right here. And then I'm going to be at 0 and then up 4. And then I would be at -1, and then 8 would be way up here somewhere off the grid. And then 12 again would be way up here. But 3 points is more than enough to graph a line. So I'm going to come over here and just draw my line. I just drew my line, and remember, it's a sketch. It doesn't have to be perfect. This one's a little harder to see because the slope is a little steeper, right? Again, we want to look at it moving left to right, just like we read. And as we move left to right on this line is definitely going down on the Cartesian plane this way. So left to right, we're going down. So that means we have a decreasing linear function. Good luck on your practice sets.